Cool. I think I'm up now. Shout outs to YouTube for making this process very simple. But cool. So like I told y'all, I'm very excited. One of the homies in the last session had asked a little bit more for some just kind of context on how to work with like databases and stuff like that, given what we've been talking about with servers and using React with Express and all the stuff we were talking about before. And, you know, there's a lot of ways that you can move now that you have some of the knowledge of like, you know, how to launch your own server using Node and Express, as well as the information you know about React. There's a couple different options. There's a couple different options when it comes to like databases and like saving data that I want to talk about. So I'm going to actually, now that I think about it, I'm going to talk about a couple, and then I'm going to get back to Firebase and say, kind of make the use case for why I personally have used Firebase a good amount of times in applications. But we'll spend most of the time probably building out a React application that connects to Firebase, and then maybe make a couple functions, and I'll talk to y'all through how we would connect those two things together and get that going. But first, let's just talk about saving data in general. And like, so now that you're kind of at a point where, you know, your React apps might be doing something unique and you're like, oh, like I kind of want to save some data. So let me just navigate to like this version of an application that might want to save some data, right? So here's our Favelinks app that we worked on a while back, right? Super simple app, just takes in some input from the user, and I'll put my thing in here. Take some input from the user from a form in one component, and then adds it to a table component at the top, right? And does some unique things, passing state around, and passing props so that the components talk to one another and send the data to one another, and then we can delete. So, you know, super simple app. But at this point, right, if anytime I refresh, this app kind of is blank again, right? So after you've added something into your table, it goes away after a certain point. And so what we would say in the technical sense is the data right now is not persistent. It's not persisting. That word persistent, you know, like think of it like, oh, he's a persistent person. It's something that sticks around or goes through, like, you know, something that is there longer, right? And that idea of persistent data is what we use databases and saving data for, right? To keep data around longer and to have data that we can pull back up whenever we really want to. So persisting data is a whole topic, right? You could look up like how to persist data in blah, 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 and any different types of languages, whether you're coding in JavaScript or you're coding in iOS and Swift or Android, right? Persisting data is a topic that programmers have to focus on, because at a certain point, you do want your data to stick around. You don't want it to just refresh every time somebody uses your application. So I want to just show you a couple different options that you can use to save data. And then we'll talk about Firebase again, like I mentioned, and why cloud-based databases are pretty helpful and you know, a popular choice for what you're doing. So first thing I want to talk about is, well, here we have this front-end application with React, right? All built in JavaScript. React is a JavaScript-based framework, so everything in here is JavaScript. Well, there's actually JavaScript APIs that we can use, like local JavaScript APIs that were created to make it easy for us to work with data persistence. So one really common one that you'll see people use often in different facets is the local storage API. Oops, I type local storage with no context and just talk about, yo, you want to store your stuff in Manhattan? That's kind of funny. I just say local storage JavaScript. And it's funny, my jaw went to dark mode real quick. I don't know what is going on here, but that is hilarious. but local storage is a JavaScript web API, right? And so the first link you see is from the Mozilla developer documentation, which will talk about the local storage property, which allows for you to, as it says here, access a storage object from the document and save data across browser sessions, right? So what the local storage API does is allows for you to save data through your browser that is persistent. It persists over different browser sessions. And it says that local storage is similar to session storage, except local storage data has no expiration time, right? So it's persistent. And so the local storage system is a pretty simple system to use. If you follow the Mozilla developer documentation, it'll talk about more of like kind of the ins and outs with this particular framework or this particular set of functions. But as far as it comes to like code and like what you would end up using local storage to do, essentially you can use local storage to set an item, and you can give it a key and a value. Once you have that key and the value, the local storage API also allows you to get that item. So you can get back the item that you previously saved with the key, right? So use the same key that you had, and then you can get that item back. You can also remove items from local storage, clear the entire local storage, and yeah, and that's it as it relates to like a simple way to save some data. But now let's talk about like kind of what's going on with how this would work and like when you could use this and when you really couldn't use this, right? So right now, you know, our React application is running on a browser, right? We are clearly on Google Chrome, and the application is running on port 3000 on my local machine, and I'm accessing it from the browser. So by doing that, right, it means that I can make use in my code of this local storage API, right? I can call these functions that were defined to allow me to interact with the browser data and set items that I want to use and pull back those items, right? And the whole system is relatively simple, but at the same time, it has to be done via, it's using the browser, which means that I'm gonna only be able to use this particular API if I'm working with browser-based web applications in JavaScript, right? And it just so happens that because React is on the client side browser-based, and we're running this application on the browser, that means that users who are accessing it can, you know, their data would be saved via this API and the functions that it provides. But there's some times where, you know, you might not be working on a browser. I guess like in JavaScript, you know, it's kind of, you know, that statement is a little up for grabs, but because JavaScript typically, you know, we are building web apps, and like those web apps typically do have some front end component to it. And those front end components are accessed via a browser from a particular website. Most of the time when we're working with React, we're building these front end applications. So most often than not, our React applications could make use of this local storage system for saving information. I think somewhere in here, it'll talk about, oh, here it is. So it talks a little bit here about another shortcoming of the local storage API is that everything is stored as strings, right? So, you know, that might not be as helpful if you're trying to store something that's not a string, right? If you wanted to store an object or you wanted to store something different. Of course, you could use JSON and use the JSON format and turn that into a string very easily, which is a workaround. But it's important to know that this particular set of functions will require for your information to be converted into strings, right? And I think somewhere else it also will talk about a limit. Okay, so it doesn't talk about it necessarily here, but it's interesting too, because what you're doing here is saving something locally onto the user's computer, right? So you're gonna want to have, you're gonna have to make considerations using an API like this on like how much data can you actually save, right? Because if you're trying to save something that's super long and just a lot, strings themselves don't take up a lot of memory. But imagine if like what you were trying to save as a string was like, multiple books long and definitely something with a lot of taking up some more memory, right? Well, you're using someone's local storage, right? So that's why this is called local storage. So this particular API is very useful for saving small strings of data, right? It could be an array, it could be a set of data that I want to say an array, but you'd have to turn that into a string, right? But ideally, right, this bit of data that you're saving is pretty small because you're going to be relying on someone else's local storage space, which you have no idea how much local storage somebody realistically has when they're on the browser, right? Like right now, I'm doing good. My computer is operating at full capacity. I think I got a good amount of space on my drawer, but there's definitely moments where it's like, oh, my space is full and I don't have a lot of space. So some of these things might break a particular API like this that doesn't necessarily work if there's no space, right? So these are some shortcomings to this particular set of functions. But at the same time, this is a very useful tool for persisting data. The local storage system is also very similar to storing like browser cookies, which you could look into as well if you're interested. I know every time you go on a website these days, it's talking about, hey, this site's using cookies to store information, right? Cookies are another built-in JavaScript set of functions that you can use, and the Mozilla developer docs definitely have them up here. So yeah. Long story short, right? There's certain considerations you have to make when you start saving data, right? You gotta make considerations about how much space you're using. You gotta make considerations about what type of data can be saved, right? And all of those will be considerations that you'd be making as a developer when it comes to how you choose to save your data, right? Or what formats you choose, what formats and functions do you choose to use in your applications and systems in that sense. And there's other options, and that's what makes this space so interesting, but also confusing and a little complicated, is that like there's a lot of moving pieces and you could do a lot of things in multiple ways. So one other thing I'll show you is like, outside of saving something locally on someone's browser, right? Typically what you might think about when it comes to like, okay, well, now I'm at a point where I want to save some data, right? It might be a database. And thankfully, there's a number of different ways that you can use databases with your JavaScript-based applications. A very popular database that a lot of people like to use when it comes to JavaScript development is MongoDB. MongoDB is a NoSQL database platform, and uses a data model that allows for you to save data in a very easy to read way, and it allows you to scale your systems very quickly as well. And so maybe in another session I'll talk more specifically about Mongo, but there's Mongo, there's NoSQL, there's SQL, there's Postgres. Postgres is another very popular database framework for folks that are looking to create their own databases. The idea here is that with these types of databases, though, right, you're getting a little bit more flexibility with how much data you can store. You can store as much as you want, really. But at the same, and you get a little bit more flexibility in what type of data you can store. It doesn't have to just be strings, right? But at the same time, you are responsible now for managing this database, which requires its own server, and requires you to make the right calls to that database to maintain it, make sure the security of it is okay, all types of things that are also very tedious processes, right? So all that being said, is, you know, these are considerations that especially like back-end engineers have to make, right? Folks that are working on the back end typically are working with databases and stuff like this too. But on the front end, you have to think about this, because what if you do want to save data in a React application, right? You should be able to figure out a system for yourself to use that's easy to understand, scales really well, and at the same time has some of the complexity that goes into managing databases a little bit more figured out, so that you don't have to worry so much about all the little things in a moment where you don't have to. As a front-end engineer, you know, most times you might not have to focus on so many of those things. But once your application gets bigger, everybody ends up having to make very big considerations on what database do I want to use? Why would I want to use that database? What does that database offer me in terms of scalability, and the ability to, you know, maintain a large amount of records and whatnot, right? So all those points being said, that is one of the reasons, these are all of the reasons and more of why I go the route a lot of the times of using cloud managed databases. And there's a number of different cloud managed databases. Amazon Web Services has a number of different web services you can use for managing your data. They have RDS, which is the relational database, and they have DynamoDB, which is another AWS service that allows you to save data. But you know, Microsoft Azure has their own cloud managed database solutions as well. And Google also has their own cloud managed database solutions as well. And one of those database solutions that Google's created, or I should say that Google operates and owns, is Firebase. And Firebase is a really developer-friendly database system, I would say. You can think about it like Firebase allows for you to build applications that are going to be using Google Cloud as you're going to use Google Cloud managed servers. We talked a little bit about servers and how that all works. I just want to kind of point y'all to, let's see. I want to point y'all to, see my compromised password there. Shout out to Safari. But I got to worry about that right now. I'm going to worry about something else. I'll worry about that later. But I'd be cracking myself up while I'd be talking to y'all. It's kind of funny. But I want to kind of point y'all's attention to like how the cloud managed systems work. And I'm not going to dive too deep into this to make it hard to understand. Rather, I want you all to kind of see like what cloud computing what cloud computing is kind of offering to people. So I'm gonna just choose this diagram. You know, there's clearly a bunch of diagrams that seem to have similar information, but we're gonna choose this one just because, you know, first one that my hand was on. But let me make it an image a little bit bigger. Okay, cool. So previously, right? I was gonna say previously on Dragon Ball Z because my brain works that way, but I don't think anybody would understand that joke. Anyway, previously, it was the case that when you were building a big application, right, you had to go out and buy your own servers, right? So the other day we built our first Express server, right? And it was running on localhost. We felt like gods amongst men because we built a database. I built a server real quick. You know what I'm saying? I got localhost 3,000. I got localhost 5,000. I got localhost 8,000. I got all these different database. I got all these different ports open on my local machine. You know what I'm saying? Like I feel like the man, right? But at the end of the day, that's all on my local machine, which means that if anybody was trying to go access those things, they really couldn't because those ports aren't actually able to receive inbound traffic from the internet, right? They're set up in a way that's secure. Thanks be to Apple for making those things secure. But so once you start getting to the point where you want to have your data transferable and people accessing your information, you need to use a server that has those permissions set up that allow for people to receive traffic, right? Those servers typically were computers that you would buy, and then you would host your own, you'd host all your information on them, and essentially keep those computers on so that they can receive traffic and respond to requests. We talked about all of this stuff a little at the top of these first couple sessions. Remember when I was telling y'all about how web development works, and like, there's clients and servers, and a client is any computer that's making a request, and a server is a computer that responds to requests, right? So typically people would manage their own servers on site. And this is not on site like, we fight in, like, I know, like, we from New York, so it's like on site when I see you. Nah, that's not what this means. this means that they, in their building on premises, they had servers, right? They had these big server rooms, or they had a couple machines that they were managing. And in this architecture of an on-site or on-premise architecture, you got to manage a lot of stuff, right? From, think about, like, you get a box of computer parts and you got to build the whole computer. And on top of that, you got to connect that, John, to the internet. You got to make sure that other people can connect to that same computer. Is you doing like all types of jobs on those servers to keep them maintained, make sure that from the lowest level of like people's ability, those servers' ability to connect to the internet, and then people's ability to create, to store data on there, to virtualization is the process of basically connecting to that server from a different place, right? All types of things you have to manage on your own. Now, what happened is that's all cool, but that's kind of a hard ask for people who are just basically getting into this space for the first time, right? In terms of like, oh, if you've never operated servers before and don't know how much they cost a lot. So managing them takes a lot of resources and costs a lot of bread. So different service providers started realizing something. These big players, the Amazons, the Googles, the Microsofts of the world, the Oracles, the IBMs, folks that have been in this space for a while, realize, hey, we got a lot of servers. We got a damn lot of servers. And we are not making no bread off these servers. But guess what? All these other people don't got servers, and they don't know how to manage these drawings. So why not create a system where we can manage servers for people and charge them for, the server space that we're not using, and they can leverage our servers and our management of those servers in different degrees to fulfill their needs. Sounds like a very good business proposition. I'm sure a bunch of white men were in a room shaking hands after that conversation. I'm sorry. I just be cracking myself up. I just be saying stuff that just be cracking me up. Anyway, so all these people, all these cloud service providers started creating these managed solutions that were allowing for you to leverage their servers. And they did so in a bunch of different capacities, and in order to like allow for you to choose what type of management of those servers made sense for you and the work that you're doing, right? So there's a couple of tiers. There's infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, which is SaaS. Each of them, as you can see, involve a different level of service provider management. The idea being that, for infrastructure as a service, you might want the cloud computing company or the service provider to set up those servers that they have in a way that allows you to, get connection to the internet, for them to have space where you can store stuff, for you to create, for you to actually, have multiple servers. And the networking piece here relates more to the internet. Servers piece here relates more to like, okay, now that you have a computer connected to the internet, got storage, can we actually create a server on it, right? And then virtualization, like I mentioned, is saying, oh, like, can I remote into that server, right? Can I SSH into that server and then mess around with the files, even though I'm miles away, right? But everything else you can manage, right? The operating system you can choose, the middleware, runtime stuff you can choose, the data you want to put on that computer you can choose, the applications You can choose, you manage all of those things, right? And for platform as a service is similar, but the cloud service provider is operating and managing more of those choices for you. They're choosing the operating system, they're choosing the middleware and runtime, but then you can just launch your application and the data you need for that application using their service, right? And software as a service is the highest tier of cloud service management, right? They are managing everything: the network, storage, servers, the virtualization, the operating system, the middleware, the runtime stuff, the data, and the applications, and then bundling that all together in a way that lets you use that system to your own desire, right? A good example of a platform as a service, a good example of an infrastructure as a service kind of system. Google has App Engine, I think is their infrastructure as a service platform. I might be tweaking. Is the whatever, when you think about infrastructure as a service, these are typically the cloud service provided solutions that allow you to launch a server via the cloud. I know in AWS we have EC2s. I'm pretty sure I think it might be Compute Engine, excuse me, for Google Cloud. They're managing all of the stuff to allow you to virtualize into a server and then launch that. Platform as a service, a great example that not a lot of people think about all the time is Heroku. Heroku is an application that is managing a lot of stuff for you, right, in the cloud. And all you do is tell it, hey, here's the data for my app, and here's my app, and you run your app, and now it's hosted somewhere else. They're hosting your application for you. There's a couple of different services that work like Heroku, but Heroku itself is a platform as a service that offers you a platform that then you can manage your own application and data using their system, right? Then software as a service. Not only is like software as a service like a huge kind of business buzzword where like there's so many applications being made to be software as a service where their company is managing all of these things for you as the user, but the software as a service model relies on a cloud computing model wherein you're leveraging a cloud provider to host all of this information such that then it's easy for you both as a developer and engineer to use, and then also then for consumers to use, right? So it's like managed software at the highest of levels, right? So I say all this to say that cloud managed solutions not only offer you a lot of flexibility with like how much management you want them to have over your systems, but they give you an opportunity to leverage kind of those companies, the Amazons, the Microsofts, the Googles of the world, to launch your products in a lot more in ways that are tied to their best practices, right? Rather than have to set all this stuff up on your own, you're using Google's resources and Amazon's resources and Microsoft's resources, IBM's resources, Oracle's resources. And dang, you know what I'm saying? Who you trust more? You trust yourself or you trust Google, Microsoft, and Amazon? That's a rhetorical question, but you should think about it. Okay, bet. So I'm hoping that makes sense. Drop it in the comments in the chat if that makes sense. But I'm grateful to give y'all this kind of precursor to like what cloud computing is offering and why it's important. Cool. So to kind of take my tangent back a couple steps, right? So there's all these types of different ways you can leverage the cloud. And one of the ways that tends to be very helpful, I should say, is in databases and managing databases and having cloud managed databases, right? So when you think about a cloud managed database, right? A database requires a computer that has networking capabilities, storage, a server, because you need to host the database on a server, virtualization to a degree, right? You're going to want to be able to virtualize into that database. If you didn't want to have the database be cloud managed, right? Either way, you're still going to need to have access to the server that has the database on it. That particular computer needs an operating system, needs some middleware and a runtime set of protocols to run. Databases require some data to be configured and an application to run, right? Whether it's Postgres, whether it's MySQL, whether it's Mongo, whatever it is, they all are applications that need some data to run, right? So technically you can manage all of this, right? And build all those things, or you could leverage an infrastructure as a service model for your database management, platform as a service model for your database management, or a SaaS model for your database management. One of the reasons why I like Firebase so much is because Firebase is like a SaaS version of a cloud managed database solution. Google runs everything. It does all the stuff for you. You know what I'm saying? All the way up to having a database made. And then on top of this, they even allow you to then add your own functions and all your own cloud functions and all add different, almost create your own APIs off of their API, which is fantastic, especially for, you know, when you're building projects that are, you need to be quick and you want to not take too much time, worrying about the database part because you're trying to just prove a concept. But at the same time, Firebase is a platform that also is built for scale. So like it says here, it's helpful for startups as well as global enterprise teams. And at the end of the day, you can use Firebase to do a lot of things. So Firebase itself isn't just about databases. Like I mentioned, it's kind of like a SaaS offering from Google that has a lot of different kind of applications built into it that you can leverage. So another big thing about it is, like, if you use Firebase, there's a lot of ways that you can use Firebase to like support your applications. And yeah, because it's a Google-based product, it actually can allow for you to leverage other cloud-based APIs that Google has. So things like streaming collections to BigQuery. So if you're getting into big data or data analytics or machine learning and stuff like that, you can extend the databases that you're creating with Google Firebase into other Google services. Again, there's other types of, you know, there's equivalent services in other cloud providers, but I've just found that Google's Firebase, I used Firebase for a while, even when I was doing mobile development. So I've been using it for a long time. And when it became a Google product, they just extended what those previous Firebase developers did to some new degrees, and then also just continue to keep the same ease of use, which are a lot of things that I look for when I'm looking to build an application. So that's my long story spiel on, you know, what this thing is and why we're going to use it and what makes it, you know, what's helpful for it. But Firebase, some reasons that like you might choose to use Firebase in your applications, right? Outside of just the database piece. I think there should be a way for us to see this. Let's see. Okay, yeah. So here's a bunch of things that you can use Firebase as a tool to do, right? So authentication is probably a big thing that you're going to want to figure out how to do in your applications at some point. Firebase has a system for managing authentication for you. Real-time database. This is a system that allows you to sync data across different clients in real time. So you could have you could be on the same application on different devices, different browsers, etc., but the data is the same, and everyone's accessing the same data, even if the app goes offline, which is a really, you know, very interesting kind of database model. Hosting, right? So if you're trying to like launch an application, right? So we talked about Heroku, we talked about GitHub Pages, but there's a similar service that Firebase offers if you want to host an application very quickly. Analytics, of course, you know what I'm saying? Like both analytics in the sense of like in your app data and performances and stuff like that, but also you can tie it to like Google Analytics and get that real-time updates on like, you know, where are people going in your application, and you know, prioritize specific places within, like see how successful your application is in certain actions and things like that, right? Yeah, all types of other stuff. Folks use Firebase for doing messaging based apps and all types of other stuff. So it's a pretty big tool, but very useful. You might hear people talk about this as a backend as a service platform, but backend as a service basically requires software as a service. So I'm just going to tell y'all it's a software as a service thing. But it is definitely something that people use to support their backend data, their backend system needs, which, you know, there are a lot of needs when it comes to the backend. So cool. So these are my use case for like, or just kind of like, just thoughts on like what makes Firebase like a dope tool. So now I just kind of want to switch gears and just kind of show y'all how you would connect a React-based application to Firebase, and yeah, just kind of get through that step, and then maybe show how you can use that connected Firebase to then maybe save some data to in a particular format. So first thing you're going to want to do if you're going to be leveraging Firebase, right? You need to create an account, and you need a Google account to do it. You don't need a Google email to make a Google account. You just need to link whatever email you have to a Google account. So easiest way is to sign up and just use a Gmail based account, or use if your school or business connects you to a Google account, as mine does, you can just leverage that login. But also, if you want, you can use your whatever email provider you do use. You can very easily sign up for a Google account. Sign up for a Google account with that existing email. And so so after you've signed up, right, and created an account, then you can go to firebase.google.com, which is the website for kind of the like homepage for Firebase. And simplest way to kind of just jump into it, we could just go through this flow that they have and just say we're going to get started here. So the get started button is going to take you to the console.firebase.google.com, which is just a different part of that website that allows you to kind of see some recent projects. So clearly I've used Firebase for a couple projects, and it also allows you to add a project, right? So we're going to just create a new project here. And there's a little kind of builder that asks you for a couple things. So it's like, okay, hey, choose a name for your project. You can use whatever, this project isn't like public facing. The name isn't public facing. It's just something to keep track of this in the cloud. So if you're building multiple things with different Firebase connections, you can reference the right one in each of your applications. So for this, I'm just gonna say fave links, right? And just let that be my unique identifier. It creates a little unique identifier for me. And I'm gonna say cool, continue. So now it's just gonna ask if I want to set this up to already be connected to Google Analytics. I can say yes. At the same time, it's not as necessary because I'm not really using Google Analytics. But some of what using Google Analytics will do is if you keep it on, it'll share some of your analytics data with Google, just so you know. And for stuff like testing and technical support and stuff like that. So if you want to share some data with Google, go ahead. If you want to use Google Analytics, go ahead. For me, sometimes I just turn this off because I'm not really, especially in this particular application, I'm not really doing anything here. Sometimes you can turn this on later if you want, but yeah, you can keep it on if you want to. I'll just be a little skeptical. I guess for right now, just to not flex on Google too much, I'll just keep it on. Cool. So then it's gonna ask you so this is the stuff about Google Analytics. So like I said, it shares a couple things with Google. Nothing crazy, but share some stuff with them. You got to accept their terms and conditions. Let's pretend like I'm gonna read through these terms and conditions real quick, you know what I'm saying, and be a good dude and know what I'm signing myself up for. But yeah, after you've done that, then you can create the project, right? And so it'll take a quick second to create the project for you. And creating a project basically is doing some stuff, provisioning resources and launching certain things in the cloud because now that you've created a Google account, you're going to be leveraging Google's cloud for all of these services that are offered through Firebase. And voila, our new project is ready. So I'm going to click continue. And this is some of the reasons why I love Firebase, right? That was mad simple. You know what I'm saying? I just had to name the drawing and then boom, I got this thing. Yeah, you know, there was a moment where I was existential crisising about whether or not I trusted Google, but we're not going to talk about that. You know what I'm saying? Clearly, I trust Google enough to use Firebase. Cool. So now I'm on like kind of like my dashboard page for my particular project. So anytime you have multiple projects, you can see all your projects here at the top, and click different, click to the ones that you want. That's why that little unique identifier name, project name, was important. But then on the left side, you can see there's a bunch of different Firebase tools that you can use. There's the analytics stuff there. There's some stuff related to build. So authentication is in there. Firestore, which is that real-time database, which is the one that kind of connects offline and across devices, and the Firestore database. And there's also a storage. Option here. So if you're looking at this for the first time, chances are you're gonna be like, bruh, which one do I use? You know what I'm saying? Do I use storage? Do I use real-time? Do I use Firestore? So each of those different databases and data management solutions do different things. Storage is good for like storing files in a organized way that you can use folders and buckets for. It's similar to kind of S3 if you use AWS before. It's a very simple storage solution that lets you save data in the cloud. Most of Google Drive uses Google Storage, which is this storage is the same service and cloud-based service that Google uses for their own services. So that's something that's interesting to know. Real-time database, this one is really useful only when you're trying to do like, you need the data to be like synchronized all the time across different devices and without API calls, and then on top of it, like we want this like offline capability and stuff like that. So it's not necessarily the type of database that you would be using normally. So this isn't like your normal type of database that you would expect, right? The database that we typically use when it comes to like saving data very easily in Google, like real-time database is good for like maybe like messaging and stuff like that. But even with messaging, they have some tools inside of Firebase for that and stuff like that. But I digress. The tool that we typically use in managing data in Google is Firestore. And Firestore also lets you do some stuff with real-time updates and things like that too. So trust me, it starts getting a little confusing when you start asking yourself, which Google Cloud service do I want to use and with my databases? The good news is that they have very sophisticated documentation that makes those things easy to understand. And like really kind of it's up to you to, based on the use case of what you're trying to do in your application, determine which of these data management solutions is the best, right? Cool. So now that you have Firebase set up, right? You can use any of these services really with the same Firebase credentials. And Firebase itself is a very flexible tool. So once you have a Firebase project set up, so long as you connect your application to Firebase, then you can use any of those services that are provided through Firebase. So let's just figure out how will we get our application set up with Firebase. And so here you see this next set of steps says, okay, get started by adding Firebase to your app. And they let you use Firebase on iOS, they let you use it on Android, and they let you use it in the web, right? And also in Unity, which is pretty cool, right? If you're game developing or anything like that. So we're going to be connecting this to a web-based application, clearly, right? JavaScript, web dev. So we're going to click the web icon. And it's going to ask us to register the application real quick. So App nickname, this is just another place to give some project clarity. So I'm just gonna name it the same thing, just say fave links. And do I want to set up hosting for the app? I don't really plan on deploying this, but if I wanted to deploy this application, it might be a good idea to set up hosting now. But like it says, you can set it up later and it's free to get started. So that's cool. I'm just going to register the app right now. And that takes a quick couple seconds, but then it gives us this, the steps to add the Firebase software development kit into our application, right? And so there's a couple of options. You can use npm or you can use a script tag, right? And so this is also a place where, based on what type of web application you're building, you're gonna want to choose which makes the most sense. So clearly, if you're doing a backend based application where there was no script tag or no HTML file, you'd probably want to use npm, right? And if you were using a script tag, right, you could put this inside of a HTML, into a HTML file that's like not using like those build tools. Because we are using npm, it makes more sense for us to follow those steps, right, and set up our application in that capacity. So what I'm going to do clearly is copy this npm install setup right here, and in the terminal, here it is. So in the terminal, I'm in the fave links folder, right? And I'm just gonna hit that npm install real quick. So while that's being created, right now, I have this SDK set of code that says I can, in order to use this, right? It says initialize Firebase and begin using the SDKs for the products you'd like to use, right? So Firebase downloads the interesting Firebase downloads all of the things that it needs to, right? And next, right, I'm just gonna want to initialize it with the right things that I need and configure it so that everything is kind of set up the right way. So what I'm gonna do is, let's see if this npm, so this npm install is still going, so it should end in a second. All right, cool. So I'm gonna just wait for that to finish. Just let me make sure I open this back up in VS Code. So Fave Links app, nothing too different here from whatever y'all probably did, right? So got the 3 components: this form component, this link container component, and this table component. And our app is kind of returning the link container, right? So typical React app that just uses a couple different components doing some interesting stuff. So just to poke at it one more time. So this is what the app fully looks like. We got the table component. We got the form component down here, excuse me, with a couple inputs and labels and a button for submission. That button triggers a function that sends that data up to our bigger link container component, which is holding some state that it then passes into the table. And so the form component's updating the state of the link container, which is then updating the prop that gets sent into the table, which changes every time we add a link, right? Cool. So I think now, okay, cool. So I think this should be done. All right, that's great. And so now I am, so now I'm able to connect Firebase into the my application. So what I'm gonna do is leverage the we're gonna leverage this code configuration that they give us, and we're gonna put it into our application to connect it. And then we're gonna figure out, you know, what kind of database are we gonna wanna use, and told y'all we're probably gonna use the Firestore database, and what was I gonna say? And then from that, talk about how we might start leveraging that API to make some database calls. So it gives us this like set of code that we can use. So I'm just gonna copy this, and in the next thing I want to do is, I can't see this button down there. Okay. So next thing I want to do is just add this to my my application. So the easiest thing to do is inside of your app, right? Somewhere in your source folder, right? It doesn't have to be in components, but somewhere in the source folder, you can create a new file. And so I like to create a new file and call it something like firebase.js. This isn't a component, so I'm gonna use a lowercase for it. And inside of this Firebase file is where we would paste this information, right? So I'm gonna just paste this information here. Clearly this is gonna work well for the React client side type of experience, because it's using the import syntax that we use normally in React, right? That we've seen before. And you know, nothing here is out of the ordinary in terms of how we're importing something from that Firebase module that we just installed, and then we're configuring it. We're creating a configuration object. Now, this configuration object that you have is unique to your particular Firebase app. So whenever you make a Firebase application, you're gonna wanna make sure you have your proper configuration stuff in order to make those relative changes to like the application and stuff like that. So cool. And like, you know, to be said is like, clearly, like, you know, y'all having this config stuff is like, would allow you to then make changes to my same Firebase database. So needless to say, after this is over, I'm probably gonna delete the app. So don't get funny ideas. How you gonna hack me? I'm like your best friend in a web dev professor. You know what I'm saying? Like, how you gonna hack me? I already got a compromised password. I need support, not more enemies. Anyway, I'm just making jokes. Anyway, so now that I have this drawn here, technically I could save this and like we could test. So let's just do that and test and see if all is well here. So there is so just there's a couple different syntaxes for like when you are getting data from a Firebase or from modules in general. So the ones that they're using are just meant to help us connect to Firebase. So this first one, this import here, is using the Firebase module we just installed, has a folder inside of it called app, and they're grabbing a particular function called initialize app. So this same function could have been accessed by way of, if we just imported Firebase, like the whole Firebase module, right? We could have also got access to this function in a different way. So I'll just show you what that would have looked like, because you might see different, if you look this up online, you might see different versions of the same kind of solution. So I could import Firebase from Firebase, right? Like the way that like we have the Firebase module that we just npm installed, and I'm gonna just import the whole thing that's returned, right? If I did that, right, then I could use that initialize app function by calling Firebase, which is now gonna use this import dot initialize app, right? What is it? Initialize app, right? So you might see different versions of similar things, right? So I'm just gonna go with the one that they use, just because, I'm trusting that they got their docs together. But sometimes once you start getting in this space, you realize people don't really got their docs together. You know what I'm saying? Like, that's why I'm really proud of React team for the recent launch of their new docs, because writing documentation is such an important skill, but not everybody has the bandwidth and time and resources to do that. Okay, cool. So clearly we're just importing some stuff to initialize the app. We got this Firebase config drawn that's pointed to the right app. We're initializing the app. And then here it's using the analytics, John. But I don't really care for this. I don't really need this right now. So actually what I'm gonna do is I'm gonna just console log out that app, right? And just to see kind of what comes back in the console after we run this function. Because I'm not using this analytics thing, I'm just gonna get rid of that. So yeah, this is just a default initialization of my Firebase application, right? All I'm doing is using this information to initialize my application. And cool. So all that being made now, I can with this all being here, like technically in order to kind of see this and save this, I could run this file in Node and just kind of test it. And let's just kind of see, let's actually see what happens if I do that. So in a new tab, I'm inside of the same folder, right? But inside of here, I'm just gonna node, let's let me that once again. Oh, see source folder. So that's the thing, because this file is somewhere different, I don't think it's gonna work because it's not tied to that package.json. Yeah, it's okay. So I can't actually use Node to run this file because the package.json that is tied to is outside of this folder. So the only way for me to kind of test that this is working is to call it in a different file. So what I'm gonna do is take this app that we just initialized, right? And I'm just gonna export it. So I'm just gonna export default app, right? And I can export this. I can export this app like however really I want. Like, and I could give this a different name if I want. You know what I'm saying? Like sometimes you'll see people name this something like Firebase, right? And then export Firebase, right? So it's really up to you. So long as you don't have conflicting imports, it should be cool. So I'll leave it like this, save this. And now that I have this exporting, I'm gonna just go to the index.js file inside of our app. So oh yeah, I don't know what was going on here. I'm just looking at this. I'm like, what is this John? Oh yeah, it's a little old school. This John is a little old. This project I did a while ago. So anyway, inside of here, now that I have that Firebase file, I can import it. So I'm gonna import Firebase from /Firebase, right? And then in the index.js, I can console log the Firebase. And let's see what goes on. What's going on with that? And I'm gonna just put a message in there for myself and say, from the index.js. In here, okay, save. Let's go back to our Favelinks app, refresh this, John. Inspect. And boom. So clearly I have something coming back. none of this information is gonna be really helpful. It's not gonna be like, hey, I'm connected. But if you look at it, one, we do know that this is working because this isn't null. It didn't come back saying that it didn't know what this was. It clearly has something here. And that thing has some properties defined on it, like our API key stuff and all of those things. So that just kind of lets you know, okay, cool, I got a Firebase object back. And by way of saying I have a Firebase object back, some of these little configurations are in there and stuff. That's the way to know that, okay, cool, your thing is connected to Firebase, and you can use Firebase now. So there's all types of services you can use with your Firebase. And so you can see more of those in the, if you continue to the console. So now that I have Firebase set up, they also have a lot of docs, like I was telling y'all. There's like some getting started guides here. There's a web SDK API reference there. Like, if your tabs don't look like you got 30 tabs open by the time you finish connecting the first John, you're not reading enough. You gotta keep going, keep hacking. So I'll continue to the console. Now that our John is set up, and our app is added and stuff like that, we are kind of good to go. And now we got to just figure out what are we going to add into this application as it relates to databases. I don't need to add this actually. So the analytics data, actually, this is actually a good point. The analytics data is interesting because if I did keep that analytics piece in there, I shouldn't have deleted it so fast. I shouldn't have been so anti Google app analytics stuff. I wonder if I still have it written here. Let's see. The cool thing about that analytics thing is that if you did keep that in there, and you launch your application, with that, right? So I could keep this here. Maybe still change this to Firebase because I exported it as Firebase. But before I do that, what's it called? Keep this analytics drawn in there, right? I'm pretty sure that by keeping this in here, right? If I go back to this should still run the same way. So this ran the same way. And got some other warning in here, but if I go back to the Firebase authentication, just come back to the Firebase dashboard, I don't think I had to refresh, but it's waiting for some analytics data. But now this analytics data that it's gonna have is coming from the app that we just created. Oh well, it's still waiting for some of the data, but yeah, I was thinking maybe it would have showed something here that let us know, oh, this John is also connected. So either way, we know our Firebase is connected. Maybe it'll show some analytics data in a different format or whatnot in a bit, but otherwise we know that we're connected to Firebase. So the next thing that we got to do is figure out, thing you might want to do is like, okay, I want to create a database, right? Like that's the whole point of us talking about this whole thing and what we're trying to do here. So there's two types of databases. There's the Firestore one and the real-time one. Firestore is like a newer database in Google Cloud. It uses the real-time database is the old database that Firebase used to use. So the Cloud Firestore is helpful for mobile, web, all types of development, but it uses kind of newer features on top of the existing real-time database that Google had, which is why both of these allow you to do the real-time synchronizing and stuff. This real-time database is efficient and low latency, but it requires it's helpful for applications that are leveraging. It's helpful for it's both of them do similar things. Let's put it that way. But the Firestore is a little bit of a more new. Is a little bit of a more new database. The biggest difference that is kind of important to note, and there's actually, let me Google this real quick because there's a oh here. There's actually a good breakdown of like kind of the differences between these here, which, you know, how do you choose a database between Cloud, Firestore, and Real-Time? But both of these databases do similar things, right? Both offer a number of different things for you. But scrolling to the bottom, it talks a little bit about the data model, right? So both are NoSQL databases, but one, the Real-Time database, stores data as a big JSON file, which is cool, you know, but Firestore allows you to store data more like collections of documents. So you can, you have a little bit more of an opportunity to store data in a more organized way with Cloud Firestore. And some of these like data models will impact how you save your data. So when you think about things over time, you might want to really think about, okay, well, which type of data model do I want to use for this type of data that I'm saving? And they have different offline support, right? And stuff for folks to think about. So there's a couple differences between them. Like I mentioned, the one that we commonly use in development, JavaScript-based development, in the sense of using React and stuff like that, most times I've used the Firestore database and haven't really had no problems. But again, the Firestore database is built off of the Real-Time database. So technically, there might be use cases for this one and the data model here, but it's really up to you to do that research for yourself. But cool. So we're going to use the Firestore database real quick and just set that up. So I'm just going to click Firestore database here. And, you know, clearly they got more compare database stuff. I think that goes to that link that I just clicked. But what we're going to do is create a database. So it's going to ask, am I going to be doing this in production or test mode? Well, clearly right now, I'm not launching this app. I don't really plan for anybody to use this. The thing about Firestore is you got to create security rules. So that thing I was saying about you know, getting access to the database, some of that you can mitigate. Like if you want to make it so that it's more secure, you can make it so that only certain people have access credentials to writing and changing things in your database. And there's a lot of different security rules that you can write into the Firestore database. Production mode will require you to write those security rules very much more granularly because they want your app to be safe. But test mode kind of just lets you set up real quick, but you're going to have to reset your security rules in 30 days. But you know, like I said, this is just a simple app to show us how we do this. If you're going to start this on your own and have a project that you want to keep long term, you can start it in test mode and then update your security rules a little later on. And there's some good documentation on that also. Okay. So next we're going to say we're going to do this in test mode. So next you have to choose where you want your Cloud Firestore to be hosted. Now, this is the thing that comes down that you have to think about with cloud providers is the cloud provider is managing your systems and stuff, your servers and stuff, but you still got to figure out where you want those servers and the machines infrastructure to be hosted. And you have the option to choose, right? Clearly, it's saying it's just kind of defaulted to US Central, but there's all types of different regions that you can choose. The thing is that once you choose it, you can't change it, right? Because there's provisioning some infrastructure for you. You'd have to create an entirely new Firebase database to do that. The reason they defaulted this to US Central is because this is what they call a multi-region zone. So by using US Central, it also will connect you to different more specific regions as a default, versus you could choose a very specific region if you know that you want your app data and stuff to be hosted in a specific place. Yeah, so we're gonna keep it as US Central. That's fine for now. And we're going to enable the database now. And it should provision and give us a new Firestore database. Yo, drop a thumbs up in the chat if you see that this process is simple enough. I know like there's some complicated stuff going on, but do you see how like you just click a couple buttons and now I got a database? Like it's kind of funny. Yeah, just find it interesting. Cool. So now we have the Cloud Firestore database. It has that same unique ID for our project. Again, if I wanted to go to a different project, I could change that here at the top. And then it kind of says, hey, you can start a collection, right? And basically, we now have a project registered with Firestore, and we can get access to that Firestore database in our React application now that we've connected it to Firebase as well. The way Firestore is structured is it uses these things called collections. Collections are a set of documents that contain data. So it's a good idea to store collections of data that is think of it like a collection of data would be like a set of slightly related data objects, but like maybe they are unique in that you have other types of data that you're saving in a different format too. So good example it says here is like, you could create a collection called users, and each user inside of that user's collection would have a unique document for each user, right? So documents are individual data records that are saved in Firestore. So this is what they're talking about between the difference between the real-time database and the Firestore database. The real-time database uses JSON as like a one big JSON file. The Firestore uses these collections and documents to save data, which is kind of similar to MongoDB stores data in a similar fashion. So, just interesting to know. So clearly, what kind of collection do I want here? I'm just gonna say fave links. You know what I'm saying? Because that's what we was doing here. So I can add the first fave link document here. Now this is kind of something that's interesting. I can manually set this, so I can give it an auto ID. So this will give this a unique value, a unique ID that can represent that particular first object. And then inside, I can figure out what are the fields that I want this thing to have. So each fave link had a name, right? I'm just saying Florida Labs, right? And each fave link also had a URL, which was also a string. And I'll just say, I don't have to actually put quotes. I'll just say FloridaLabs.org and save that. And so now I have a collection. I have its first document, and it kind of just one object that has a couple fields in it. And so the thing is, like when you create the Firestore stuff, you do have to kind of initialize your collection. But once you've initialized it, you could delete it if you want. So I don't think it's right clicking, no, but I could delete this collection. A collection automatically gets deleted when every document inside of it gets deleted. So if I deleted this document by clicking this 3 dots system here and delete the document and get rid of this, it'll get rid of the fave links collection too, right? And so, wait, I guess not. I guess they playing with my emotions in this. I guess if I delete this collection, I can do it like that. Well, that's cool. Before they didn't make it so that like it would delete after a certain point. So that's actually cool that we can keep the fave links collection without having to manually set it each time to have a default value. You kind of do need to manually set it clearly this first go around for it to kind of exist in the database. Or you have to use certain Firebase functions to create it. So I'm gonna say name. I'm just gonna put some data in there though, just so that I have something in there, and then we can mess around with that. All right, cool. So last thing we're gonna do is figure out how to connect this to our application, right? So we already installed and connected Firebase, so we're already balling. You know what I'm saying? We got Firebase kind of coming back. So leveraging, and clearly we can like bring this module into different parts of our application and leverage it. So I don't really need it in the index.js, but where I might want to have it is in, let's say, our app.js. Our link container is then the function, is the component that has the the real logic of our application, right? Once a fav link gets removed, we do some stuff here. Once handle submit gets called, we do some stuff here to update the state, right? And to basically, this state changes the state array of fav links, and then that array of fav links gets passed into our table as props called link data, and then the form is what's really triggering this handle submit function. So maybe after every handle submit, right, we're gonna want to save this data to our Firestore, right? That makes sense. Like, instead of just having it update locally and change the state and all of that, maybe we actually want to save this data. So let's kind of just see how we might connect to Firebase or connect to Firestore, and then make that happen. So Firestore is a really dope tool for building applications that we would consider, we call them Crud Applications, CRUD, which stands for create, read, update, and delete. Crud applications are like the basic functions you have to define when you start building like database-based applications, right? So any application leveraging a database typically has these 4 functions defined on it, so that you can get the data from the database, read the data, right? Create, add something to a database, update, and delete. So we're just going to go over like one of these functions, but then hopefully you can see how maybe 1 or 2 of these functions, and then hopefully you can see how you can kind of go about building this out for yourself as well. So first thing I want to do is show you how you can connect your Firestore. So clearly I'm in my link container. So what I'm going to do is I'm going to import that Firebase that we created before. So I'm going to say import Firebase from, now it's inside, it's up a folder, Firebase, right? And so Firestore is a particular, it's a particular module in the Firebase kind of application. So if we look back at how we kind of got set up with our original kind of Firebase stuff, right? We have to import something from the Firebase app and from the Firebase module to then start leveraging those other things. So first thing I want to figure out is, okay, how can I actually add and update this database? So if you look at the top of the console here, there's a go to docs section. Highly recommend that you click the go to docs section, and you can see some of these things in more details. So let's see. So under the build tab is where you can find the Firestore docs. And these are what I was mentioning, is all the docs they have for like getting started and like starting to make some changes into Firestore. So let's click getting started real quick. And so we already created a database. We did that part already. We added in test mode. That's all good. And then now it's asking like, okay, well, where are you? What kind of what's it called? What kind of in development environment are you using, right? So we were using Firebase as an npm module. So then it says we need to import both Firebase and Cloud Firestore in order to initialize it and use it and stuff like that. So essentially now what I want to do is leverage that Firebase function here to get some data from the Firebase config. So we have Firebase set up already in the application. So now we're going to just want to make sure we can get Firestore really from our Firebase instance and leverage that in our application. So technically, from what it's talking about here, let's try it one way first and then see if we have to do it a different way. So it seems like they have a new kind of hook that we can use to actually get the database. So I'm just going to import the, because we already initialized the app, right? So this already kind of happened. And then after getting the app, after initializing the app, it seems like they just created a new constant value for the database. So let's see how we might just add that to our initializing function for Firebase, and then how we can use that in our application. So let's go back to our Firebase configuration system here. And so underneath this get analytics drawn, I'm gonna just do the get Firestore as well. And then create a constant, just call it DB, and just say get Firestore, like it does here. And cool. So dope. So this line will connect us to Firestore. So let's just test this and see if I'm not mistaken, we're gonna have to get the Firestore inside of our link container. But let's just play around and see what happens next. So I'm going to leverage that same get Firestore function in here. And I'm going to create a new instance of the Firebase data store. I'm just saying const db gets get Firestore. All right. Okay. So now that I have this John set up, let's just save this real quick. Make sure we don't get no errors in here. I did get an error. Firebase, no Firebase app default has been created. Where's this? Oh, so this is coming in from this one. So let's get rid of this. Make sure that this still runs. Okay, cool. So you have to use that get Firestore function inside of the same place where you are, in the same place where you're initializing your Firebase. So now that I have this, if we want to leverage that Firestore database, we can also export that database that we just created so that we have a reference to that as well. So what I'm gonna do is, before exporting the whole kind of Firebase app, I'm just gonna export a different thing. I'm just gonna export, let's just export this, this constant database. So we have the database also as an export, and then we can export the Firebase function, the Firebase app in and of itself. So if somebody specifies that they're looking for the DB, we can give them this. But if they're just importing from this entire file, we'll give them the entire kind of Firebase app as it's related. Make sure that this still runs. All right, so this is cool. So now inside of the inside of the link container drawn now. So now what I want to do is import, let's just import the database from Firebase, from our Firebase function. And let's just console.log the database from, cool. So it's still, we're still pulling the whole Firebase application, but it is clearly kind of, so I guess we're still pulling the same Firebase application regardless of our, let's do this. So we're pulling the same application. Let's just test this then now and see if we can make this change. And then I want to confirm one thing before I send y'all off. Cool. So in order to reference what we're trying to do here, right? What we're trying to do next is just add some data to our Firestore database. So there's a couple of functions that we have to, or there's a couple of like, what's it called? Like objects that we have to kind of get reference to from the Firebase Firestore module that we installed. So I'm just going to import this, and then we're going to take a look at this function a little bit more. So I'm going to import the collection and import add doc. I don't know why it's doing that, excuse me. And just following the docs, right? It says, in order to add something to Firebase, Firestore, I should say, excuse me, they give us this try catch block with an example of us adding a new document reference to a specific collection. So I'm gonna bring the code in, and then we're gonna just talk a little bit about what we see going on inside of there in a second. So let's just, for the sake of clarity, I'm gonna create a new function. Let's go send to Firebase, or send to Firestore, I should say. And then that will take a fave link and then send it to Firestore, right? That's our goal. So I'm just gonna copy in this try catch block here. So the try catch block is used so that you can catch errors and exceptions, right? So you try whatever bit of code you have in this first block, and if there's an error and exception thrown, then you can catch that error and then like either console log it so you know what went wrong, or just make changes and make some moves differently to that. So we're gonna keep the try catch format for this, but here we could change some stuff here. It says the doc reference. Clearly what we want to change here is our reference to what collection that we're talking about here. So clearly the reference I'm changing this to is to fave links, because that's the collection that we created. And then here it's asking me what is the data that I want to add to it, right? So there's this object that is being passed. So rather than pass this object, because fave links are stored as a JavaScript object, right? I can just pass the fave link, right? I could also take, I could very specifically say, set this here to be related to the data inside of the fave link. So I could say, instead of name, I could say fave link dot name or something, right? And like fave link dot URL, right? I could do that, but that's a little redundant given the fact that the fave link itself is an object, right? So I could just pass the fave link, and that would be what it kind of destructures to. So I guess for the sake of clarity, I'll just keep it here so that y'all see what I'm doing is I'm creating a new object that's going to be saved to Firestore with the particular name and URL from our fave link. Then after this line runs, right, we're gonna get back a document reference ID. And now we're seeing kind of a very interesting we're seeing a pretty interesting set of steps going on here, where inside of our try catch block, right? Which is funny that they're doing this like this, because this is where I say documentation be going funny sometimes. Inside this try catch block, we see this await syntax, right? This keyword await that's saying add this document is going to await something, and then it's going to get this doc ref back, and this doc ref has a particular ID, right? And we're going to console log that. This await syntax is a new syntax in JavaScript that kind of relates to what we were talking about last class about asynchronous functions that get called when with promises. So in the last class, I don't want to take too much time to deviate to this, but maybe we'll talk about it in our next session. But in our last session, we saw some really interesting syntax with the fetch API, right? Where when we use fetch, we called fetch. I think it was, we called fetch, right? And like, I think it was like fetch.get, and there was like a website that we went to, right? But then after the fetch, right? The fetch then had some .thens chained to it, right? Y'all might remember this kind of interesting syntax from what we did with the fetch API. What I told y'all was that each of those functions from the fetch library returned a promise, an asynchronous promise. And we use .thens to get the data back after each promise. Well, that .then syntax was used very widely until like the latest update in JavaScript, where they introduced this async await syntax, which allows us to await for asynchronous data chain transfers, so long as we mark a particular function as async, which is really just saying that, okay, well, I want my function to wait for these various excuse me, y'all, these various I want my functions to wait for these various asynchronous operations that then I can use in my calls and stuff like that. So to use an async await function, all you have to do is mark the function as an async function. So here, since a Firestore, this arrow function, I want to make sure that it knows that it's an async function, so I can use that await syntax, this await key here. So I just got to add this keyword async in front of this arrow. That will just let this function know that it's an async function, which lets me use this await keyword. I have to do this, or this line is going to blow up on me and give me some problems. So I'm going to save this. And the next thing I want to do, just to test to make sure that we kind of are connected here, is in our handle submit, right? So after console logging, that's fine. Before we change the state and stuff, I'm just gonna call the send to Firestore function and pass the fave link. And cool. So save this, and then let's see kind of what happens when I add a new fave link. Let's see what happens when I add a new fave link to the fave link, John. Oops. Can't resolve that with runtime regenerator. I don't deal with the. Ooh. Wouldn't be me live coding if I didn't get an error in the final stretch, huh? That's funny. Why is this giving me this error? That's so weird. Very weird error. I've not even seen that before. Let's see. Bro, so weird. Well, when I get weird errors like this, I like to back up a couple steps and make sure that I'm not doing something crazy. So I'm gonna just go back a couple steps. I didn't really change too much. So let me just mark this as async so I don't, actually, I gotta go back. So let me do this. We'll figure out where this thing might have got messed up. Okay, cool. So, okay, that's my problem. Send the Firestore async. Am I putting the async in the wrong place? Interesting. I don't know why this is blowing up in my face right here. Did I? Yeah, I don't know why. So let me just do this real quick to see if this will fix this. I don't like doing my my functions like this, but I'm gonna just do it like this real quick to just see if this fixes some stuff. What? Man, I do not like when I be live coding in my journal, just be going crazy. Interesting. Okay. I don't know what that issue is. I'm gonna have to debug that on my own. But so I'm gonna just put this sent to Firestore. And what I'm gonna do is basically what I'm gonna do is, instead of using the async await syntax, because for whatever reason this is blowing up in my face, I don't wanna belabor the point. What I'm gonna do is just rewrite the async await syntax as like with the .thens. So after this first add document function gets created, then we will have we should be able to make use of the returning value, which would be this docref thing. So I'll get rid of this. And with that docref thing, we should be able to console log. So I'm gonna just save this now. All right, so it got us back to this. Let's just see if this connects. Okay. No errors got thrown, but was I calling that function anywhere? No, that was my problem. Whoops. Okay, so let's try it one more time. Expected first argument to be a collection. Whoa. Collection. Oh. So this was that. So that was that thing I was tripping about earlier, was in the so in the docs, right, we got to grab the reference to our database, but for them, they do that here. And our so let's do this rather than whoops. So let me just, for now, just to kind of show y'all, I'm gonna just get the Firebase, the Firestore database as the as my export, and then inside of the inside of my, well, let me do it this way, bro. Let me try it this way. Export the Firebase, and then inside of the link container where we actually want to use the Firestore database. So I'm going to import Firebase from here, and then where we are trying to access this where we're trying to access the database, I'm just going to say Firestore. So let's see if this will actually let me connect to the Firestore database. Oops, then I got to get rid of this other one. Where is that? Y'all see my struggles. Essentially, I just got to make sure that I'm connecting to the right Firestore database. And typically, before there was a function that we could use called Firestore like that. But in the docs, it was showing this different way of using this get Firestore John. But for whatever reason, I wasn't grabbing our export the right way. Literally, I'm like so close, like I could smell it, but I'm like, dang. All right, so let's keep this export. And then maybe what I got to do actually is get the database that way. And then, oops. Okay, cool. All right, bet. All right, y'all. Ooh. Ooh, thought they had me. It was just because I need to, for this export to work, right? I'm grabbing the database from my Firebase file, right? To do that, I still exported this database from the get Firestore and the initialization. I'm still exporting as a default the regular Firebase, but because I want to particularly get this database module that I've exported inside of the link container or wherever I want to get access to my database, I need to make sure I call it with the curly braces, right? So it's particularly get in this database. Then I can console log that console log was coming back right here. And now I'm expecting that now this function, which was asking for this database, should work. So say that's already saved. So let me just test this one more time. And of course, I'll put this up on GitHub, right? So clearly this fave link updated. We saw it update the table. And now we see that it's inside of our send to Firestore function. And after it finished, it wrote that document with that new ID. So if we go back to Firestore now into our fave links table, right? Inside of our Firestore database, we should see that. So it created, oh, my fault. I called it with a lowercase l, but we should see that new document that got created. So I should change this. Let's see, fave links, capital L here. And Oh yeah, so I should have wrote there. Maybe when I made this first database, I didn't do it. I didn't add it the right way. But either way, now our app is synced. So if I want to add a new link, right? So I'm gonna add another one, camo.com, right? Submit. So now that gets written to this database with another ID, ZGY7. So then I go back here. Oh yeah, so it is writing to the right one. Maybe I just made this database. I made this database messed up. So let me delete it. So we have this one collection called Fave Links. That's the same one that I am writing to in this add document function here. But now every time I add a new Fave link, right? In my database, you can see it's adding these new documents to my database, right? So I already kind of have that first function of create in the CRUD function done, right? To read is another simple function. I'm not gonna go, I'm already a little over, so, but I'll show you that if you want to figure out how to get these functions written, right? The best resource to use is the documentation, right? So in here, not only do they have, okay, how we get started. This section was a little gave some little issues, but when this DB that they're referring to, you have to use that database that you're getting from Firestore. So it doesn't show you this here clearly, but exporting this would be helpful so that you can then bring it into all of the other pages in your application that need that database reference. But we did the add section, right? So adding data or managing data. You can also update data using this function, using some of these functions. But read data, right, has some functions as well. So if I want to get the data from my, if I want to get the data back from the Firestore, right, I can get data from a specific collection similarly, right? So I can make a reference to a specific document in the database, and then get that information back as a snapshot that I can put into my application. So reading the database data is a little interesting because you can get the instances of all the data. You get the instances of all the data as a snapshot, and that snapshot then allows you to, one, check that it exists, that it's not null, and then or not undefined, excuse me, and then you can use that snapshot data to act as the data that's come back. So yeah, so if you're gonna read, if you want to create your read function, you might want to use this get a document function or get document section here. Update is somewhere in there as well. I think it's an add or manage. So if you were trying to, let's see, it's probably an add data, but if you scroll down a little bit, there's another function, set a document. So set is like what you would use to update a document. So you can get a reference to a document. Oh no, set document lets you set the document with like specific params and stuff, like things that you want to change. But then let's see, update. Update a document. It's on the right-hand side. So if you want to update a document, that's another function that they have defined. You need to get a reference to in order to update a document, you need to know the document ID. So in order to get that document ID, you might want to save that somewhere so that you have that document ID, and you can iterate. So whenever you read a document, you can get back that document's ID. And then with update, you can pass that document ID and then update that particular document with whatever values you want. So you create a reference to that particular document, right? So this is them creating that reference. And then using that document, using that ID is what you need to use to make the reference, right? So the reference takes in the database, takes in the collection name. So this would be Fave Links for me, and then whatever my Fave Link random ID is. So one of these drawings that's coming back in the console. and update. And I pass that reference into the update function and then set the data. So that's how I would update. And then if I wanted to delete, similarly, I need the document ID that I want to delete. So then I'll just kind of call this delete function, which is dope. There's some other stuff to Firebase. So, maybe in a future session, I'll talk a little bit more about some of these deeper functions like sub collections and stuff like that. But for right now, that's more than enough to show you how you can create a CRUD app in terms of using the Firestore API that Google Firebase provides. You can read the data. Clearly, when you read the data, you can get access to those data, to the data IDs, right? And the data ID will allow you to also keep a reference to those things later. So good idea might be if you have a big array, keep an array of the IDs or something. That way you can update them and delete them very easily as well. But yeah, y'all, hopefully this was a cool primer into Firebase. I'm sorry I got a little hectic at the end, but live coding, that's the name of the game. But yeah, it's a pretty simple API to use, and definitely I'm around for questions. So if you do have any questions as you use it, feel free to hit me, and I'm happy to help. So yeah, I hope y'all find this useful and any of what we talked about useful, and like adding data to your React applications, and leveraging Google as a cloud managed provider for your database needs and other services. So like I said, there's a lot of cool stuff you can do with Firebase outside of databases, like authentication and analytics and stuff. So pretty dope tool to know, and pretty simple to use. Even hosting your applications, you can use Firebase for. So good tool to know as a web developer, and grateful that y'all sticking around and getting that knowledge. So appreciate you. Let's see. Yeah, that's really it on my end. Appreciate everybody for sticking around, and I'll tap in with y'all.